Hello everyone, welcome to my channel Academy of Fine Learning. In this video tutorial, we'll learn about the Java inner classes. Make one thing clear in your mind that the inner classes and nested classes are two terms which are used interchangeably in Java. So the objective of the video is that after watching this video, you'll learn about the inner classes. This is the medium level and the intermediate level between the beginners and the experts. The video is made of keeping the objective off, and the advantage of using the inner class is using practical programs you'll see, and the notes you will get of all the programs which will execute in eclipse and display into the video. Okay? And we'll see the video and the output, we'll see the program and the outputs, and we'll keep it into the notes, and the notes I'll share with you so that you can get benefited by all the programs which you have executed. We're going to execute, and also with all the details which are available regarding the inner classes. So there are four types of the inner classes available in Java. First is a non-static inner class, then we have static inner class, then we have anonymous inner class, and then we have the method local inner classes. So I can tell you that most of the students who learn about the inner classes, they know about the non-static inner class and they know about the static inner classes. We'll learn today in this class regarding the anonymous inner classes and method local inner classes also. So let's start with the note and sharing the screen. So what is a inner class? And basically an inner class is nothing but, as the name implies, it's a class within another class. If you write a class, name of the class is suppose outer. Inside there, if you write another class, suppose the name is inner, you are giving, okay? Then this class inner has become the inner class of the class outer. So this class will be known as the outer class, whatever the name you give will be known as the outer class. If you give the name A, then also it will be outer class. If you give the name outer, then also it will be a outer class. Similarly, if you give the class name inner, it is a inner class. If you give the name A, then also it will be a inner class, because it is defined inside the body of the another class. That's it. You've given the name outer class for the outer class and inner for the inner class. So how can we say that we have the non-static inner classes and static inner classes? A non-static inner class is a class which is not having any static keyword, as simple as that. If we provide the static keyword over here, then it becomes the static inner class. So now we'll see one by one through this note regarding the each and every examples. We'll go through their properties of the nested inner class, then the nested non-static inner class. We'll see that what are the properties it has, how to create object of the inner class, what is the difference between the nested inner class, is the non-static and static ones, what's the difference between the anonymous inner classes and method local inner classes. All this thing we'll learn one by one. So let's go through with the nested inner class. In a nested inner class, it can access any instance variable of the outer class. It's a very important point. It can access any instance variable of the outer class. So let's give an instance variable integer x is equals to 10. As per the claim, class inner can have an access of the inner class x. Let's see that. Print something. Write a method over here. Method is public void show. See that we'll put system dot out dot ln, and we'll try to print the value of x. So it's basically accessing the member of outer class from, correct? That's what it does. Plus the value of x. Concatenate the value of x. See, there is no error is displaying here, because yes, it's possible basically. That's why it is not giving any error. From the main function, we'll try to create the object of the outer class, and we'll see that how an inner class object can be created if it is a non-static inner class. If it is a non-static inner class, then how the object of the inner class can be created through the object of the outer class only. So if you want to create the object, first you have to create the object of the outer class, correct? I've created the object of the outer class. Is it possible? Is it happening? Yes. Correct. Now using that object only, you have to create the object of the inner class using the object of the outer class. Actually, what happens when the Java program is compiled, we'll create many class files depending upon each and every class name. So here it will be inner dot class. So these class files are the byte files, right? Byte codes. And here for the main class, we'll create another. Yes, inner main dot class. But this inner class, as it is the inner class of the outer class, it will be specially identified by the outer. How? Outer, the dollar sign, inner dot class. So here also you have to mention that thing to the compiler. That is the inner class is part of the the class named inner is the inner class of the class outer. So I will specify to the compiler by outer dot inner. Now we understand. Okay, the inner class is a inner class for the class outer. Now you can see that how to create an object ob2, the object of the inner class we are going to create. So for that you have to make use of ob1 dot new, and then just to give the name of the inner class. That's enough. Yes, now the object ob2 is created. Otherwise, if you remove this line and if you want to create the object without ob1 like any other class, it will give a compile time error. Correct? While the compile time error they are giving because the inner class object cannot be directly created. See this, I'll remove this also. This inner class, if it is a non-static, then their object cannot be created without the help of the outer class object. The outer class object we have to create first. So that's the only way we can create the object. Yes. Got it. Now this ob2 will see that it will call the void show and it will be able to access the member of the outer class or not. ob2 dot show will call the method of the inner class. See this now? Yes, it's able to access the member of the outer class from the body of the inner class. It's able to access the member of the outer class even if it is private. Even if it is private. Even for private, it can access the variable x from the body of the inner class, although the x is defined inside the body of the outer class, not inside the body of the inner class. Here, even you can change the value of x, even modify. You have to remove then private here. Sorry, make it int. Now modify the value of x because the value of x now is a picture of value of this x, not value of this x. The x variables have a different copy in the inner class. If you use a method over here, print value of x, then also it's possible. Name values will be, now you see that create, you'll use the object of the outer class and call the show one method. It's possible, right? Because show one is defined inside the body of where? Outer class. Correct? If you execute this code, we can see that two values are coming for x. One is 10, another is the 100. This 10 is the copy of the integer x which is defined inside the body of outer, and this x is a variable which is defined inside the body of inner. However, if you don't define this, then by default it can access the variable of the outer class. Here both will give the result 10. Correct? Both have given the result 10. Hope that it understand and make your doubt clear regarding this. Even if it make private, then also it can access. 10 is coming. This is the first point that can access any instance variable of outer class. So we'll enrich our node using this program. So when you download the note, you can get entire understanding. I'll format the note later and give it to you in a good form. Now the second point is that the first point can access a non-static inner class can access any, even the private instance variable of the outer class. This is the first point we learned. Next point, we'll learn that we can have access modifiers, private, protected, public, and default modifier. So one particular program is given to you, a very simple program. Copy and paste over here. I'll explain it to you. So this is the outer class and this is the inner class. Yes. So as this point says that we can have access to private, protected, public, and default modifier also for the class. So for this class, we can make public. Make it public. Yes, because the main class. But we cannot make another class public, as we know the rule. It's giving error. Because in a Java program, a single class, which is the main class, can be made as a public only. But if we cannot make it as private, yes, it will throw error. You cannot create any object. Make it protected. When to make it protected, it will throw an error. So by default, it can be a class can be at a maximum default or public. Public, that also one for a Java program. You can make it default. By default, it will be a default only access modifier. So if you have a doubt on access modifier and related thing, then you can please watch my video on access modifiers Java. So, but the capacity is given to, now we'll come to the topic. The capacity is given to the inner class. Inner class can be private, no issue. But the object cannot be created for that here. Here we are going to create the object in a different way. Yes, the same thing actually. First you are creating the object on the fly for the outer class. Then by using that, we are creating an object of the inner class. So what we have done in the last program is quite same to this. I'll show it to you, the alternative. If you make the inner class private, then you cannot create an object of the inner class. If you make protected, then it can be possible. All error has gone. You can execute very easily. Yes, in a nested class method is being printed when you're using the object of the inner class and calling the show method. Line 12, it is jumping to the line number 4, and this thing is in run. We are getting the output in a nested class method. It's interesting, right? So you can even make it public. Public is possible, but that's not our motto. Our motto is to show that private and protected can be done in case of nested class. That cannot be done for the other classes. That's the benefit we can get here. So what we're doing here, now come to this topic now. The last time how we have created the object, we'll create another object and show it to you. In one, new object name. How we have done in the last time, in one, we have created one object of the outer class first. Yes, ob1 equals to new outer. First we did this. Now this, by using this ob1, we have called dot new, and because you're going to create the inner class objects and you're using the default constructor. This is one way of creating an object of the inner class for a non-static inner class. Again, I'm telling, for a non-static inner, for a static inner class, the technique will be different, and I'll show it to you very soon. Another way, both ways are same. Here we are creating the object first, then you are using the object over here. In this example, first we in a single line, in this line only, we are creating first this object. So this object is created on the fly without a name. This is the object creation on the fly. We are using the dot operator, then everything is same. This part is same. Dot new inner is same here. So instead of creating ob1 in a separate line like this, here you are creating it on the fly without giving a name. This way of calling show, and if I write down in1 dot show, and this way of calling show are both exactly same, but written in a different forms. Same output. Nested class method, because this thing is executed twice. One is getting called by the in1 method, another, sorry, in1 object, and again it will be called by in object. Same method show. So we'll keep this also as a to our note. Formatting I'll do later. Also I'll copy. Please execute all these programs. You will have a better and clear understanding. Okay, we can't have a static method in a nested inner class. It's very clear actually. You cannot have a static method in a nested inner class. It's very simple. Nested class, this is the non-static nested class, correct? You cannot make it static. As simple as that. When you make it static, it will start giving you error. Error. Why? Execute, what will happen? Will that display an error here. The method show cannot be declared static. Static method can only be declared. So that thing is the output. Give this also enrichment to this node. And if I do the formatting layer. I'll go with the next type of the method, that is the static inner class. We'll go to the static inner class now. Static inner class is like the static member of the outer class. We copy this code and enrich if possible, and if required, it will be possible to enrich the code. You see here that this static int x is equals to 10 is given. Yes, and this x is being accessed over here. It's static inner class. How it is different from the non-static inner class? Just by a single static. Yes. Now we can see another difference over here. How the object is created for the static inner class. It's different than the non-static inner class. Here, object of outer class not required to be created. So you don't need any outer class object to be created. Directly you can create the object of the static inner class. Again, it should be static keyword given to make it a static inner class. This will be taken as the static member of the class outer. So here what we are doing, new object is created, name is new OB, using this syntax just to specify like this, like the previous example of non-static inner class, outer class dot inner class name. Class name dot inner class name, the object name, new operator. Then it's very simple, outer class name dot inner class and the default constructor you are calling. So it's like creating any other object. Just the difference here is that you have to specify where the inner class belongs to, outer dot inner. And if you call with the object, the show method, it will display and it can access the integer's value x. If it is static, then only. This, enrich this code also. Now, if you remove this, then what will happen? If you remove this static, and here error has started coming. Cannot make a static reference to the non-static field. It will throw an error. Throwing an error. So this code also I'll make. Yes. Here also access modifier can be used. Here also static, I mean, you can make it public. Yes, static. You can make it public, then also it will run. Come on. It's running over here. You make it protected. Then it will be running, guys, very easily. If you make it private, then the object cannot be created. It will throw an error over here. From the type our inner class is not visible because it is right. So I'm showing for method. When here because you're trying to create the object of a class which is private to the outer. So from the outside the body of the class you cannot create, as simple as that. If you make the public static void main inside the body of there, then that's a different thing. If you make it over here, that's a different thing. Then error over here. Again, are you getting the point? Then the main class should be removed from here. And it should be named as this part should be given the main class. But as you can see here, there is no error is displaying because it's a private to the outer. So inside the outer only you can use public static void main and create object over here. this is the difference. This is the similarity between the inner class, which is static, and non-static both. They can be used using the different access modifiers. There is no need to give this example. Okay, I'll give it. Protected. Also, now we'll go to the next level of the next type of the inner class, anonymous inner class. It's very interesting actually. It's completely different. Anonymous inner class are declared without any name at all. It doesn't have a name. You have to understand where the anonymous inner class is there. This is the beauty of an anonymous inner class. And you will like it. The more you learn about the anonymous inner classes, you'll be amazed. Is used as a subclass of a specific type. Let me show you using this code how the anonymous inner classes can be defined. So in inner class, you can see over here that in this class demo we have created a void show method, correct? And here we are creating an object. Here this is the anonymous inner class actually. This is the anonymous inner class we have defined over here. Yes, there is no name of the class. Now the void show is again used. This is our overriding of the void show. You're using super keyword to call the super class show method, and we are then printing in the main class. That is this line is displaying for the subclass show method, and this line will call am in show method of super class. So the output will be first am in the show method of super class, then am in the main class. So, fine example. See, the show method. I'm in the show method of the super class. Now from the class main, I'm creating an anonymous class. Make it sure that static keyword is not required. It's not mandatory, but we are doing for our own simplicity. Yes, I'll show you why. So leave the static out of your mind if you get some confusion. Okay, just to imagine that we are creating demo d is equals to new demo, and we are not giving a semicolon over here. Rather, we are starting with a bracket. The first time you are seeing this sort of thing, I think. I'm organizing the code for you. Say this demo d, d is the new object created for the class demo, which is the void show, correct? And this is considered as the anonymous inner class, which is there inside the main class. Okay, and void show method is overridden over here. The same method is written. Same method which is there here, that is written over here. And super.show means it will call superclass method. What is the superclass method? This will be considered as a superclass method because we are creating a object and then calling super from the show in the same method. Yes, and system.println am in the main class. First this line will be called due to this line number 13 will call line number 2, 3, 4, and then line number 14 will be printed. If you create an object of the same object, if you use the same object d and call the show method, because it is static, it's possible. Otherwise you have to create an object of the super class, then you have to use, yes, you have to use the object of the super class. This is the super class, na? Main class is the super class. This is the anonymous inner class. Yes, anonymous inner class, correct? Anonymous inner class is started actually. The anonymous inner class method is very interesting. Many students get very much confused regarding this, but it's very simple. Yes, so to access a static, to access the anonymous inner class as it is make as static, we can call it directly using d.show and can get the output. First in the show method of the super class, then it's showing I'm in the main class. The code, sorry, no. Yes, now I make some change. If I don't make it static, you can see that it will throw an error. Back here, it's telling that cannot make a static reference to a non-static field ID. The non-static field ID, na? But we are calling it from the public static void mains. So static, from the static field, how can you call a non-static field? You have to make it static. Static field can call only a non-static field, and it's D you are using, correct? It's not a concrete class object. They are the difference is making. So you remove this line. If you want to make it non-static, this anonymous inner class, then use the old strategy of creating first. Yes, creating the object of the superclass first using this technique, and you're using this superclass object dot d dot show. Now we can use this anonymous inner class. This anonymous inner class is being referenced by D. This show method is called then. Then it will be giving the same output. Yes, so I'll enrich the note using this code also. I hope that this node will be very much useful for you, for your understanding of different types of the inner classes. It can be used as a little alternative for implementation of inheritance and method overriding. It's another property of anonymous inner classes. I'll show it to you using a simple example. Let me go up here, write a bit of code. We can write down some class hierarchy. Class A. Class A. Class A has public void show. So this method having a single line system.out dot, and we are printing I am in show. Is show. That should supposed to be displayed, right? Is that should supposed to display. We call the show method of the class A, and we'll create another class B, which will extend class A. So you are getting the smell of inheritance, correct? And we are copying the same code, writing class B's show. So now class B has two features. It has public void show, which it has defined for its own definition. The name of the method is exactly same. See this? The return type is same, the name same, the arguments are same. Type is void, name is show, there is no argument for both the methods, line number 3 and line number 10. But implementation is a bit different. Here the implementation is it's printing I'm in class A's shows, this string is printed, here the another string is printed. Yes, B is getting the features of A, so this is available to B. This is also available to B, correct? Why? Because B extends A. Now begins. If we want to do this kind of thing, then we have to make a way of creating what? The objects and then calling them. You have to use the object of A first, and then use the object call show. Then which show will be called? OB1 means class A's show will be called. Same thing can be done to call class B's show. How? Yes, now two objects are created. OB1 is the object of the class A, OB2 is the object of class B. Now which show will be called will depends upon the object, that which particular object is calling this. For this, we can see that first this will be called, this will be printed, then this will be printed. First we are calling the show using the, although the name is same, void show, depends upon the instance of the class, it is calling a particular method. This part, class A and class B inheritance, is known as the inheritance, and this part, that is public void show, is given the same return type and same number of arguments and same arguments. I mean the data types of the arguments, actually it's two things, data types of the arguments and the order of the arguments, number of the arguments, that makes the methods differ, right? So here each and everything is same between these two methods. So and it resides in the two different classes which are connected through inheritance. Makes these two methods overridden, not overloading. The method overriding is a technique of runtime polymorphism. Overloading, that's a different concept. If you have forgotten that or if you want to revise that, please watch my method overloading video. Two different concepts. Here we support runtime polymorphism. In method overloading we support compile time over polymorphism. Let's stuck to the point where we are. Let's stuck to the topic. To avoid all these things, we can have a very good technique by using anonymous inner class, the topic which you are discussing. Just delete this part and this part very easy. Just modify this very easy. How? Don't give this semicolon. Subject. Then we'll write down some lines of code which will display, which will prove that we can just modify and overwrite the method show. How? We'll make it the same method declaration over here. So we'll copy here. As simple as that. This makes your life simple. Right line of code. Is it true? Now call this method. From we'll call the method from here from the outside. Call from here. So what will be happening? Will it show error? There is no compile time error. Rather, it will come to the am in the anonymous. You're getting that? This is the anonymous class. It's creating an anonymous class. It's like an anonymous class body. If you're using this anonymous class reference OB1, if you use the object, if you use, then what will happen? It will call this particular. Yes, so no need to go for the method or to create the object of the V and all these things. In this way, it can support you having little alternate for implementation of inheritance and method overloading. Now to the final point, the method local inner class. I can tell you that many expert level programmers also don't go through with the method local inner classes, but it's very interesting. So the inner classes can be declared within a method of an outer class. Then it will become a method local inner class, where it should be declared within a method of an outer class. So the outer class, here it is the outer class, na? Is the outer class. If we make a method over here and inside the method body, if we create, suppose here is a method, I'll copy this code. We have given that example, so not get confused. Here, class outer. In the outer class, there is a method. The name of the method is void outer method. Here, now you can see that the method. Method we are getting a interesting, correct? It's quite interesting. Inside this void outer, not inside the class. Inside the class there is a method. Inside that method we are creating an inner class. Yes, the inner class. Then you are coming back from the inner class. This is the general body of the method. So the main point is we can declare a class inside the method of the outer class. Yes, so what we're doing over here, we're creating a inner class and it has a method. The name of the method is the inner method, which is printing inside inner. The object of the inner class in a very simple way. See, there is no need to specify that outer.inner or outer.inner over here, because it is in the local of this method. So this class inner is considered as the member of outer method. So there is no need to specify where inner lives on, because inner lives in this block. Which block? Block of the void outer method. Yes, this block resides. So inner y is equals to new inner. Y is y dot inner method. So this object is now calling this method, so that will be inside inner method will be printed. From the class main, what we are doing, we are creating the object of the outer class only. We are creating the outer class only. The outer class object, definitely it can call any method of the outer class, and outer method is the method of the outer class, so it can be easily called. We are calling it very easily in line number 20. Line number 20 will jump to the line number 2. Line 20, when you are calling outer method, it will jump the Java control to the line number 2. It will print that inside outer method. Then it will go and compile this part, and then you can understand that here we are creating an object y, and object y is calling inner method, so it will print inside inner method. The output will be inside outer method, then inside. That's it. Outer method first, then inside. So we'll end the code. Okay, the same code you have used, you have not write it, so modify the output. So that's regarding the different concept of class. But this video will help you out in understanding all sorts of the and all types of the inner classes. Please like, comment, and subscribe to my channel. Thank you very much.